Hello, calculus students. We are working on section 2 of the P2 section in the book. There was day 1 homework from P2, and let's roll through notes today, looking more at linear models and rates of change, and a little bit of focus on parallel and perpendicular lines. If you recall, parallel lines have the same slope, and perpendicular lines are lines that have slopes that are opposite reciprocals. So opposite in their sign, meaning positive or negative. All right, so given 5/8, what would be a parallel slope? A line that is parallel will have also a slope of 5/8, and a line that comes in perpendicular, remember perpendicular is going to be one that makes right angles with it, that will be a slope of negative 8/5 because we have opposite and a reciprocal. Parallel slope to a line that has a -7 slope will be -7. Perpendicular slope will be positive 1/7. If a line has a 0 slope, the parallel line will also have a slope of 0, which means this is a horizontal line. And then a perpendicular is going to have the undefined slope, which describes a vertical line. And vertical horizontal lines meet at right angles. Sketch a graph of the equation 2x minus y minus 3 equals 0. What I think I want to do is I'm going to solve for y, getting it into slope-intercept form. So I'm going to take this 2x minus y minus 3 equals 0 and solve it for y. So I'm going to, I'm going to add y to the other side because this will make the quickest or least amount of moves. And that will give me y equals 2x minus 3. Switch it around and I'll have y equals 2x minus 3. Now I'm going to sketch a graph of that, recalling that this is my slope and this is my y-intercept. So starting out with b, 1, 2, 3, there's -3, slope of 2. That slope is up 2 over 1, up 2 over 1, up 2 over 1, and put your line right through it. Problem 59, write an equation of a line through the point 2, 1 that is parallel to this line. So here is a standard form of the line. I could calculate the slope off that. Most of you are probably familiar with solving for y, so I'm going to go 2y equals 4x minus 3, solve for y, and that's going to give me 2x minus 3 halves. From this, I can now conclude that my slope was a 2 for that line y sub 1. I want to make a new line. I want my new line to be parallel. So its slope, my new line y sub 2, will have a slope of 2 as well. All right, so we want to go through the point 2, 1. So we're going to have through point 2, 1. And that's going to give me then, I'm going to go into y minus y1. So y minus 1 equals the slope 2 through x minus 2. And that's coming off of that point slope form of the equation. Okay, and I'm going to just leave that can be my answer. Now, part B says let's make it perpendicular. Well, we already did a little bit of work. We know our original equation, stealing it from over on the left, was y1 equals 2x minus 3 halves. That indicated then that it had a slope of 2. Our new equation has to be, is perpendicular to y1. Therefore, my slope of the second equation is going to be the opposite reciprocal. So this was positive 2, we're going to be negative 1 over 2. Now that I have the slope and I know the point that it goes through is 2, 1 based on the given information there, let's write the form of the equation referencing back to point slope. So it's going to be y minus 1 equals negative 1 half x minus 2. And there's our slope that's, or our line that's perpendicular. Problem 71, determine whether these points are collinear. And I'm given 3 points. 3 points, remember, are collinear if they lie on the same line. So without graphing it, I'm going to look at the slopes between these points. So between the points. So let's take a set of 2 points there, negative 2, 1, and negative 1, 0, and calculate out the slope. Y minus y, x minus x, done in the same order, gives me a slope of negative 1. Next, let's check out a different set of points. So I'm going to use this point and this point. So negative 1, 0, and 2, negative 1, 2, negative 2. Y minus y, x minus x, negative 2 over 3, negative 2/3. Whoa, we can stop right there, can't we? Compare the slopes. If they lie on the same line, they should have the same slopes. And my first one was a slope of negative 1. My second one between those 2 points was a slope of negative 2/3. They are not equal. Therefore, these points, the points are not collinear. And then we get into problem 80, straight line depreciation. A small business purchases a piece of equipment for $875. After 5 years, the equipment will be outdated and have no value. So they want us to write a linear equation giving the value y of the equipment in terms of time, and our x variable is time. The y value is the value of the equipment, so kind of like $1. And we know they purchase it for $875, and then 5 years it will be completely outdated. So what I'm going to do first is figure out how much per year we have to kind of lose on this equipment, depreciating it out. So I'm going to take 875 and divide it by 5 years. I want that to say years. 5 years. If I do that division, I will come up with $175 per year is what it needs to depreciate, so decrease. This is like a rate of change, correct? Or in other words, it's a slope. All right, so question A says to write a linear equation giving the value y, so y equals, and then I need to take our initial value of the equipment and then subtract off $175 for every year that has passed. And that should give us, so in 2 years, I'm subtracting $350 off the $875, for instance. Part B, find the value of the equipment when X was 2. Oh, we just talked about that. When X equals 2, I get Y equals 875 minus 175 times 2. That's 875 minus 350. And that will give us a grand total of $525. Part C, estimate to 2 decimal places of accuracy the time when the equipment is $200. So I want to know when Y equals $200. So what is my X value then? Well, let's take our equation and calculate it out. So Y is 200. $875 minus 175x, and solve for x. So let's subtract 875. That'll give us negative 675 equals negative 175. That's good that we got two negatives. Negative 675 divided by negative 175 will turn out to be positive, and x will equal 3.86 years. And they asked for it to be 2 decimal places, so there you go. All right, there's the homework, and you will have to write some of those equations like we did at the end. Good luck.